that, after you go to course, then it'll bring you to announcements. I have several announcements. I have a general welcome one which talks about the class. I have 3 tutorial videos there for you. One of them is how to register in ALEKS. That's what the top one is. The second one is how to find the videos inside ALEKS that go with the different kinds of problems, because it's a little bit of a pain. And then the third one talks about the knowledge check. And once you get into ALEKS, fully registered, the first thing that's going to come up is a knowledge check. For those of you who have never used ALEKS before, are there any of you, this is your first use of ALEKS? Several of you, but almost a third of you. Okay. The knowledge check is vital to your life the next several weeks. That sounds pretty threatening, doesn't it? ALEKS is a SMART program. You take this knowledge check, and based on that knowledge check, which determines different skills you already have, you could have 250 problems a week of homework online, or you could have 15. The better you do a knowledge check, the fewer homework problems you have, because you've already demonstrated that you have the certain skills. Okay? So that knowledge check is really valuable. Don't blow it off. The worst thing you can do is to click on I don't know. You do that, you're guaranteed to have a whole bunch of that kind of problem come by Sunday night. And by the way, in ALEKS, you have homework due every Sunday night. It says at 11:59, but that could be Eastern time. It was one year. Last year it wasn't, but one year it was. So count on 11 o'clock instead of midnight. Besides, you don't want to be up working math at midnight on Sunday night. Okay? You want to relax a little bit over the weekend. And so anyway, take the knowledge checks seriously. You'll have about 3 or 4 of them throughout the semester. They do make a difference in how much work you have to do. Okay. Also in the announcements, I have this financial access code that you can see here. Right there's the actual one for your class. This is in Blackboard. Now, what is this financial access code? Easy for me to say. My grandkids go to another college because they're competitive swimmers, and WSU doesn't have that sport. They both have both academic and athletic scholarships. Basically, they both have a full ride. And they don't get their financial aid the first day of classes. It usually comes about a week later. So if you have that kind of a case, or maybe you need to pay it out of your pocket, but you need to wait until the first of the month for payday, okay? That's where this temporary access code is. It is not an extension, okay? It is not a substitution. What it does is it allows you to get into ALEKS tonight, hopefully, if you're not already, so you don't get behind, but at max, it only lasts 2 weeks. At the end of 2 weeks, if you haven't converted it over to a full access code, a paid access code, either through your financial aid or whatever, however you want to pay it, then it shuts down and you've lost your 2 weeks of homework. Zeros. You don't want that to happen. Sometime before 2 weeks from when you use that temporary code, and you don't have to use that temporary code. If you got plastic that you can pay for it, fine. If you bought it at the student union, fine. If you found it online somewhere, fine. Those are all opportunities that you can have to do it. Now, I'm going to show you how to get into ALEKS in just a moment. And as soon as you get into ALEKS, the first thing, if you're not registered already, is going to ask you, what is your access code? And in that case, you either paste in this temporary, or you pull out some plastic and give it to them, you know, digitally. And then they log you in on it. Or if you have the physical sheet of paper that has it on it from the bookstore, you enter that, and then you get into ALEKS and you enter your contact information and that kind of stuff. Be sure you put an email address in there you check very regularly. Okay, it may only allow you to use your student address. I don't know, they may have changed that. What'd they do last year? Do you remember?
I don't.
Okay. Anyone? No, don't remember. Slept since then. Okay. By the way, if I keep messing with my glasses or looking like I'm frowning or something, it's because my dog bumped my glasses, and my nose is really sore right now from the nose pads on these things. So they're bugging me terribly. So I apologize if I look fierce or angry or something. I'm really not. Okay, now. So anyway, you'll do that. What about a book? What about a book? Do you need a book? Well, maybe, maybe not. Inside ALEKS, there is an e-text. It's not the easiest to use, but it is there. Okay. It's kind of it's a little bit difficult to search for a certain topic in it. If you don't know exactly what chapter and paragraph it is. Its search function is not friendly, is what I'm saying. Now, you can order, now I was told in 012 that it's only $29, a hard copy, what they call manuscript. It's a 3-hole punch binder kind of a book that you can get. Now, I recommend that you get a book, whether it's actual hard copy from the bookstore or whether it's this manuscript book, because when you're doing homework on your computer, it's a real hassle to get out of the homework, to go to the book, to go back to the homework. But if you got that textbook right there and your notes from my class right there, then it's much easier, okay? Now, do you even need the textbook at all? E-text or not? Hopefully, I'm going to give you 90% of what you need. But that doesn't mean that it isn't nice to look up some additional examples in the book while you're doing stuff or studying for a test or what have you. And they do have some good chapter review kinds of materials that I don't necessarily bring out in class. So I advocate getting one. I certainly don't require it. Okay. That's a choice that you're going to need to make at that time. Okay, now back to this. This is just a PDF. This might be more useful in some other classes. This being an in-person class, I probably won't use this, but in online classes, it's used a lot, where you have something, you take a picture with your phone, you convert it to a PDF, and then you email it to the teacher. But that's a process of how you can do that. Now, let's go to the next thing, information. Up here. In the information block, come in. How you doing? Brittany, right?
Bethany.
Bethany, oops.
It's
Well,
okay.
at least I got the first letter of the alphabet. Speece, I think, is your last name.
Mhm.
Okay. Your old seat's taken already.
I kind of figured. It's okay.
Now, this in information is my syllabus, okay? You can open it up, you can click on it. Okay, right there's the link for it. It'll open in a new page. It's worth reading. It'll tell you, don't email me at james.carter@wichita.edu. It'll tell you to email me at pymanjc@aol.com. Now, this schedule right here is obviously, well, no, I actually updated the dates on this one. This is very approximate. Okay, very syllabus. It'll tell you how I figure my percentage of the grade and that sort of thing. Although that may change very slightly. Okay, it'll be to your advantage if it does. Now, the course materials is also very important for you because that's where I put all kinds of extra stuff. First thing I have in here, okay, these are those same 3 tutorials that I talked about earlier. No big deal. But notice this ALEKS logo up here. This is your link to go from Blackboard to ALEKS. And that is the only way you can get there. You cannot get there directly. The university designed it that way. You have to go through Blackboard. Okay? And you click on that link, once you're registered, it'll go automatically. You don't have to sign in. Now, I also have these 2. This one is my pacing guide. Here's my copy. It's what I'm teaching every night. Now, there are slight variations on it, from day to day, but by the end of the week, I'm going to have everything in that particular week covered. If you scroll down through this pacing guide, you can see what we're doing each week. You can see where the exams are. Okay. The holidays. Thanksgiving, different stuff. The final, which is on a Saturday. But look at this. Here are my old version videos. Now, here's 0201. That meant February 1st. Okay. What did I cover that day? Introduction, calculator, equation chain. On the 8th, I covered quadratic equations and my method of factoring, which if you had me in 012, you know what I'm talking about already. Okay. On the 9th, I talked about quadratic equations some more and the quadratic formula, okay, for solving equations and so on. These are live links to videos. If you miss class, you can go to those. Now, I already told you, those of you who are here early, that you can tune in by clicking a link that I've got in here and watch live my Monday and Wednesday morning shows that I'm videotaping live. Okay, those won't be posted to YouTube until roughly 24 hours later. But you can watch those live if you want to. If you anticipate an absence or something. Yes.
Is it the exact same material Monday and Wednesday as is for?
Yes, it is. I mean, there'll be very slight variations in pacing, but yes, it'll cover the same subjects. Okay. This is not an excuse to just routinely miss class. Besides, you don't want to give up a half a letter grade on attendance grade. Okay. But it is an asset for you if needed, yes.
What was this under again?
This is under the pacing guide, which is in course materials, right there. Okay. Then I also have this Zoom link down here at the bottom of course materials, and that's the link that will take you directly to the Zoom class on Monday and Wednesday mornings. Okay, Okay,
Okay.
that's what I told you might happen.
Mhm.
Well, if it works right, it has happened.
Okay.
I'm still having a little bit of issues with the link for this class to that class, but I think I've got it worked now. Okay, any questions about what I've got in Blackboard? Now, let's go to the ALEKS link up here. Just click on it, and it will take you directly to ALEKS if the internet doesn't go down like it did. Right here is where internet went down on Monday morning. And this first class is the only class in the whole semester that I really depend on having internet. Oh, well, I've made best I could out of it. Now, this is my homepage. It looks slightly different than yours, okay? Yours will have a scale like this that shows how much, this is people who've already taken the knowledge test, what percentage of the total class information they know is what that represents. But I'll be able to see how much time you spend online, and it will time out if you just turn it on and leave it on. Although I don't do that very often, but I have done it on occasion. You know, I can certainly see how you're progressing. Now, I've already talked to you about how to register. Okay, when you click that link, if you haven't registered already, you know, it asks for the access code, it gives you the opportunity to buy the hard copy, and then go to the knowledge check. And I've talked about the knowledge check already. So after that knowledge check, then you're going to get a screen something like this, and then you click on the homework link and go directly there. And that's kind of the process and how it works. Any question about how to get into ALEKS, how to use the assets that I put in Blackboard for you? By the way, when I put an announcement in Blackboard, it will automatically send you an email. It will usually be worth your time to read it, because I don't just trivially send them out, or at least I try not to. I try to have it have some relevance if I do send it. Well, if there are no more questions there, then I'll get out of that and get into some other stuff. Now, after my experience Monday morning, once burnt, twice learned, right? So I created in PowerPoint all of these pages I've just shown you in Blackboard for the future if I need to. Now, in the syllabus, there is a sheet like this. This one isn't even currently dated, but you know, it shows you the general path. Here's the pacing guide. There's the video list as an example. And then here's the link that I gave you for uploading the class materials. So I just made that as backup in case I ever go down again on internet. So we're ready to actually get started on this. There are a couple little things that I want to do outside of this PowerPoint before I actually start it. And you don't have this in your packet. I don't put this in the college algebra packet, but I just want to take a moment and show it to you. I do have it in my 012 packet. It's called clue words. What these are words that in word problems would give you a hint that you have to add, subtract, multiply, or divide on one or the other side of the equal sign. Okay. For those of you who aren't familiar with my dialogue, I consider an equation to be solved like a sentence in English grammar. The verb is the equal sign. Is equals. Okay. and you've got what's in front of it and what's behind it, and combined, you know, Jane ran, and then the preposition to town. So you got this expression on one end, Jane, you got to town on the other, and ran is your verb, your equal. Now, an equation must be balanced. There must be the same value here as here. So because of that, as long as we add or subtract or multiply or divide the same amount from each side, we've preserved the equality of our equation. Okay, it's kind of like a Libra balance scales. My birthday's in October. We got class that night, I think. But at any rate, you got to always maintain that balance in an equation. Okay. Now, again, these are different words. Some of these pretty important. By can be division or multiplication. Factor, you're going to hear me use that word over and over and over again until you're tired of it. Okay, and all of it. Me too. Okay, but anyway, I just wanted to take a moment and show you this. The next thing that I want to show you is this, and this I believe you do have in your packet. Look and see if you have an expressions writing handout. This is what it'll look like on the top. The problem pages are the same as the one you had last year. All but 12. 12 of them are different. Either deleted or added. It probably would be close to the front, or it might be at the very back. I think I put it in these packets. Maybe I didn't. Look about the first 3 or 4 pages. Well, maybe not. Okay. Well, apparently I didn't put it in here. And this is just kind of a hit and go thing anyway. This is just taking those clue words and putting them into symbols, is what this is. Okay. If I look at the answer sheet on this, the expanded version of it, 5 more than W. Well, more than says you're going to add. So 5 plus W, or preferably W plus 5. Because with conventions, the way we do things, we usually put the variable before the number. Don't have to, but usually do. Okay. So this one, you could have either 3 plus M or M plus 3. M plus 3 would be the preferred. Easier to see. Okay, and we go on down. 3 times B, that's one I want to expand on. Okay, now here is the best answer for 3 times B. You know what? You can have 3 times B. You can have 3 times B. You can have 3 times B. You could have B times 3. You can have B times 3. What I don't want to see is this, because it might be confused with that. Okay. Let's see. Don't use crossbones, because you might confuse it with a variable. You know what I mean by crossbones? Pirate ships flag, skull and crossbones, the old time signal. So we don't do that, we don't do this. Okay, you also can use this. Or, although I discourage this one again, but this one is okay. That times dot up in the middle, that's not a decimal, that's a times dot. Okay. Different ways of writing that particular multiplication and division, or multiplication rather. If we scoot down a bit, this is actually one that gives some people trouble. Some of the division stuff right here, these two. 1/2 of n. Now, that's computer time. This is what I would expect to see, not that. I don't want you to ever use slanting fraction bars, except one exception, and I'll show you that in a little bit. I'm going to gripe at you if you do, and if I gripe enough times, I might take off at points. Okay, now that and with this in the middle, not this. That's something different. This is 1 divided by 2n. This is 1 divided by 2 times n. So it makes a difference where that variable is when you write these fractional expressions. Okay? Now, what's that number, somebody? Anybody? By the way, you're in the worst seat in the house because trying to see over this stuff. Or one of the others, either now or sometime. But you, if you sit there, I don't care. What number do you think that? What do you think that is? What?
Simplify.
No, it won't simplify.
7 over 11.
I picked one that wouldn't. What?
7 over 11 or 1 over 4 or
No, that's not what I'm looking for.
11 over 7.
Okay, you are saying that this is 11 over 7.
Oh, wait.
Are you sure that it's not 1 and 1/7?
Yeah.
Do I make my point about vertical fractions? Okay. That's why we use flat fraction bars in algebra. Also, when we start factoring out numerator and denominator elements, if you start putting slanting ones where they're over here and over there, good chance you're going to lose track of a number somewhere. Whereas if you've got them vertically stacked, it's very obvious what goes with what. Okay, so just routinely assume you are expected to have vertical for our flat fraction bars with vertical fractions. Okay. Now, back to this. I showed you that this can be 1/2 n and it can be n over 2. This one can be 2/3 n, or it can be 2n over 3. Okay. So it's just little details, but still yet, that's something that causes people to make mistakes. And you're going to find out that throughout the semester, I put a big emphasis on error prevention. Do things in a way that help you not make mistakes. Okay. And you're also going to find out that I put an emphasis on error recognition, gaining the ability to find your mistakes and see when you made a mistake so you can fix it before it hurts you. Okay, or you do a whole bunch of work and have to do it over again, which is even worse. Okay, so anyway, I just wanted to go over a couple of these things very briefly before we got into the other stuff. Okay, now, so let's get started in this. There we go. That should narrow my view in the projector. Just to the screen. Okay. Linear equations. Whoops, wrong button. Linear equation, L-I-N-E. Equations creating a line that you can graph. Okay. Linear equations all fall into general category. In depth, we're just going to get a very brief start tonight on this. There are conditional equations. That means that equation is true if and only if you have only one precise answer. And then we have identities, which is an equation that's written in such a way that no matter what number you substitute into it, you will get a truth. Okay? You can't pick a wrong number unless maybe it's imaginary. And then we have contradictions, or equations which are written in such a way that no number will work and make it true to balance. Okay? So we do have those three types within this with one variable. We're going to solve fractional equations. And then literal are equations that instead of using numbers, they use additional variables. But you solve them just like you do the regular ones. And anything besides the one they asked you to solve for, you treat it like it was a number instead of treating it like it was a variable. But we'll get to those later also. This is where we're headed. Now, you don't need to write this down. This is just one of hundreds of equation solving strategies. Okay, I'm going to show you one that I use myself. Simplify, simplify, combine like terms, which is more simplify. Then they consider clearing fractions and decimals and that kind of stuff, and I'm going to show you something on that. Here's the second page of that. Like I said, we don't need to write that down. Turn to this page in your handout, please. You should have the first two written down, if I'm not mistaken. Do you not? First four? Okay. Well, I need to go through them anyhow. And I need to change my projector setting, which should open up to the full board now. Okay, here we go. The equation up there is 3 times x minus -4 minus 2 equals, what's that, 12? 12 plus
3x
thank you,
minus 2x.
minus 2x. Okay? Now, the first statement in my chain says convert minuses to plus if needed. Well, I need it here. Notice how that's written up there. Notice how this is written here. The difference is in typing, you can't offset the height of the negative sign. Okay? So that and this means the same thing. In either case, a negative negative makes a positive. So when you have both of them there, it changes. So we've got 3x plus 4. Now, if we wanted to, we could change this to plus -2. There's not really a whole lot of value in doing that. You can or don't. It's up to you. Okay? Sometimes I do it, sometimes I don't. 3x plus 3x. And technically, I could make this plus -2x if I wanted to. And again, that's one of those things that's kind of, you can do it or don't. Okay? But this one is important here. Now, so we have completed first step. Second step, use the distributive. That only happens if you got parentheses or brackets or braces. Okay? So You know how hot and miserable it is in here in Kansas? Just think, there's a song by an artist who came from Colorado. John Denver is his name, coincidentally with the name of the town Denver, Colorado. But he created a song called Rocky Mountain High, and high in the Rocky Mountains of Colorado. Very nice song. But doing the distributive property reminds me of Rocky Mountain High. See my Rocky Mountains? As I distribute that 3 to both of these values, 3 times x is 3x. Bring down the plus, 3 times 4 is 12. And then I've got the minus, plus, -2, and all of this. Now, honestly, if I were solving this problem, I would combine some multiple steps on the same line, but right now I'm intentionally going step by step, one thing at a time. Okay, so we've used the distributive property. The next circle says simplify. Well, when I took 3 times x and wrote 3x, I simplified. When I took 3 times 4 and got 12, I simplified at the same time. Okay, so I completed my simplify step, but this also says combine like terms. Well, I've got some like terms in this thing. Here, these 2 are like terms, and these 2 are like terms. Have exactly the same variable component to exactly the same power. Okay? If they meet those criteria, then you can combine them or blend them, if you please, into one value. So here we now have 3x plus 10 equals 12 plus hidden 1x. Okay? So we have now simplified. Well, here's your first critical step. Now, what I call critical steps are things that I look for to give you partial credit when I grade your tests. This is important stuff. Critical steps are anything that you do the same thing to both sides of the equation. Okay? Add both sides, subtract both sides, multiply, divide, square root, power, absolute value, whatever. Okay, as long as you do the same thing to both sides, that falls into the critical step. So what this is saying, get all the variables on one side of that equal sign and get all the numbers on the other. But we're going to do that in 2 steps right now instead of a single step. Okay, so here, what I need to do is I need to get this x over on the other side. And I actually draw little arrows like this on my homework or on my work. So how do I do that? I add its opposite. Okay. By adding its opposite, I wipe out those 2. And over here, I now need to simplify again. 3x minus 1x gives me 2x. And then I've got the 10. And over here, that becomes 0, so I've just got the 12. Now, I still got plain numbers on both sides. So that brings my next critical step, which is collect the numbers on one side, the plain numbers. Okay? So I want to get this 10 over there. Minus 10, minus 10. When I do that, I simplify, which gives me 2x equals 2. Right? Now, my goal is to get positive 1x. But I've got 2x. So how do I do that? I do the opposite. 2 is times x, so I divide both sides by 2. And that's my next critical step. Now, if this were a fraction, if I'd had 2/3 right here, I'd multiply both sides by 3/2, the reciprocal, okay? If I had a negative here, multiply both sides by a negative to get rid of it, to give me a positive here. So anyway, I've got this. So this, I told you there was one exception for you guys on my flat fraction bar thing. Right here is that exception. When I'm showing that I'm dividing both sides of an equation, that's the only time that I use a slanting fraction bar. Now, when I get ready to simplify again, then 2 goes into 2 once, 2 goes into 2 once, 2 goes into 2 once, 2 goes into 2. In other words, 2 divided by 2 is 1. And 2x divided by 2 is x. And then I box my solution. Okay? Yes.
So when we're doing our work, you don't want us to show it as if you're just putting like a straight line to show division. You want us to do this side. Like what you just did up there.
Repeat your.
So like for like when we do our homework or to show our work and stuff, do you want us to write it like that? Like, okay.
This is the way I prefer. Now, as long as what you do is technically correct, there can be variations. But this is just kind of the method that I would prefer that you show it in. Okay? I don't know if that is that an adequate answer for your question?
Yeah, that's exactly.
Okay. So you see this, I mean, there are lots of equation solving things. Most of them are kind of simplistic. This one will deal with any linear equation, any equation. Okay. Now, if you have square roots in it, it gets a little more complicated, but the basic process still works for solving equations. So that's why I give this to you. Any question on this before I go on? Anyone need just a moment to finish copying? Okay, be quick. While you do that, I'm going to take a sip. Anyone not ready yet? Okay. Here's our first equation to solve. I'm going to give you a moment to get started on that one. Oh, let's talk about phones for a moment. Put them on silent. Do not use them to text, Twitter, or whatever. I get highly offended. We'll probably invite you to leave class for the rest of that day. However, as far as I'm concerned, phones have one singular use in this class. Sometimes I may put something up here on the board that would be real burdensome to copy down, but yet it's worthwhile for you to have. So I'll say, hey, if you want to take a snapshot of that, that's okay. No videos, I'm already making videos. But if you want to make a snapshot of something that I'm doing, that's okay. All right. Now, I will talk to you, remind me tomorrow night, right at the beginning of class, to talk to you about calculators. They are allowed in this class, and there are certain kinds, some are better than others. Don't go out and buy one until after I talk to you. Okay? I'm going to save you money as well as give you a better product. So anyhow, let's be solving this problem. Basically, I'm going to use the process of the chain. I gotta get it down here where I can reach it. Okay, I'm gonna use the distributive property here, and I'm gonna use it there. So I got 4x minus 20. And I've got 4x minus 10. What?
Wouldn't it be 4x minus 8,
Where?
the last number?
Oh, here.
Yes.
Yes, as a matter of fact, it was. This time I did that mistake on purpose. Okay, this time. But the point is I will make mistakes sometime. Okay. I do. I make really random mistakes once in a while. That kind of stuff. If you see that and if you question it, please bring it to my attention. I will not feel like I'm being called out. I won't be offended. In fact, you will be doing the class a favor, because the worst thing that could happen is if we leave that 10 up there, we work the whole rest of the problem with 10, and then we have to redo the whole problem. Or worse yet, you got the wrong example in your notes for homework. So please, if you see me make a mistake, and like I said, I make them, I just do. Mention it, please. So anyway, I have used distributive property. Now I need to combine like terms. So I've got 5x or minus 20 equals 4x minus 8. Now I can decide to put the variables on either side, but I generally put them on the left. And there's a reason when we get into graphing for that. But they can be on the right. So anyway, I'm going to put them on the left. So that means that I need to get this 4x over here. Now, sometimes you can move the variables and the numbers at the same time on the same line, but you're bringing in an opportunity to make a mistake. So I usually deal with the variables and the numbers in two separate lines. That's just me. Okay. How do I get it over there? Add negative 4x. Add negative 4x. So that gives me 1x minus 20 equals negative 8. Now I need to get rid of this add-on. So I want to move it over to the other side. So add positive 20 to both sides. Can you see that green okay? Yeah. Okay. And when you do that, then finally we get 1x equals, in this case, what, 12? And that's the solution. Okay. Question about this? It's just like the chain, isn't it? Okay. Simplify. Change signs if you need to, distribute if you need to, simplify. Every other step is simplify. Okay. Now, I think they're going to work it. Sometimes they work them a little bit differently than I do. But basically, more likely than working differently is they're going to leave out steps. Now, what they did different than what I did, okay, you see this line and that line are exactly the same. And then they went straight to here, which is so far the same. Whoops. Got it too active of a thumb there. And then they quit showing you steps. And that's where I filled in how I went from this to that. Now in ALEKS, sometimes it'll require you to give your answer like this. Sometimes you'll just put in the 12, and sometimes you may have to put x equals 12. On my tests, generally speaking, unless I ask for a set of the answer, unless I specifically ask this whole X equals, because the X is the label for that 12. It tells what that 12 is. It's that X, that box that you didn't know what was inside it. Okay? So much about that. Here's another one. Again, we got distributions to do. Okay, we did the distributions. Everyone got that step correct so far? Yay, nay?
Yes, sir.
Okay, now we combine the 2x and the 6x. If it helps you, you can do this. And over here, do that, showing what you're combining. Now, I'm not necessarily encouraging you to do that. I'm just saying you can, if it helps you not to make mistakes. Here, they didn't show some steps. They skipped some steps here. What they didn't show was they didn't show taking this over here, adding +6 and +6. They also didn't show taking this over there by adding +20x and +20x. Okay. I used to absolutely hate it when I was sitting in math classes and the teacher would start putting some stuff up on the board. Back then it was those old black chalkboards, which with a vision problem that I happen to have makes those hard to see in the first place. But they would jump from this to that, and I thought, what the hell did they do? How did they get that? Well, this is how they got that. So most of the time, I'm going to put that in there, and I would encourage you to put that in there as well. Okay? Again, error prevention. Well, what did they do here? Again, they didn't show how they went from this to that. Well, it's a little bit obvious, but what they did was they divided this by 16 and they divided that by 16. Would it be easier to understand if you saw this? These two cancel, giving me 1x. Here I end up with -8/16, and then I have to reduce it to 1/2. Okay? So that's why it's always good to show these critical steps. And that's why I give bonus, or not bonus, but rather partial credit points for them. Okay? It shows me you know what you're doing. Questions on this one? Yes.
When you say partial credit, are you meaning if we get it wrong, you don't, like, if we get it right but don't show, we still get all the points, right?
If you get the wrong answer but use the right process, like for example, maybe you added this number together and that number and you got -13. But if you still work this problem down correctly, process-wise, the whole way, you would still get 3 out of 4 points. Okay? Because you had correct process. I placed more value on process than I do on answer. I mean, answer is ultimately what you need. But in the process, I place more value on process, that you're using the correct techniques. Did that answer your question?
Sure.
Any other questions? Okay, you get rid of my scribbles. Okay, let's skip over that one because it's more or less, decimals. I hate decimals in algebra. Even with a calculator, I hate decimals in algebra because it takes longer to put the decimals in the calculator than it does to work fractions. Huh, that's a spot on my slide. So, what do you suppose that 6, 13, and 2 up there are? Bingo. Yes, I did what's called clearing the decimals. Okay, I cleared the decimals. I noticed each one of these only had 1 digit behind the decimal. If any of them had had 2 digits behind the decimal, instead of multiplying everything by 10, I would have multiplied everything by 100. Or if one of them had had 3 digits behind the decimal, I would have multiplied everything by 1,000 to get rid of the decimals, because I hate decimals. So I end up with 6x minus 13 equals 2 times 5x minus 8. Now I need to distribute this. Minus 13 equals 10x minus 16. Okay. I need to take this 10x over this way, minus 10x, minus 10x. Can I do both in the same step, or do I need to do them separate lines? Separate, okay, that's cool. So I get here negative 4x minus 13 equals, those go away, minus 16 or negative 16. I want this 13 on the other side, so plus 13 plus 13. And that gives me negative 4x. These two go away, equals negative 3. Uh-oh, this one's not going to look pretty. Well, I got to find 1x. So I'm going to divide by negative 4 and divide by negative 4. The 4s and the negatives cancel over here, so I get 1x. And it's a hidden positive. Over here, I just negative and negative cancel, so I get simply 3/4. Now, they did it without doing that. They kept the decimals the whole way. So I wanted to show you that for contrast. Okay. They actually made a mistake in this slide. I know what that red splotch is. It's that negative sign. Yes.
What did you call that thing again at the top where you put the?
Clearing the decimals. Yeah, you can actually do that with denominators if you've got fractions too. But you got to find the least common denominator before you do it. And we'll deal with those problems a little bit later. Okay. Now, which way is easier? In my opinion, clearing the decimals is vastly easier. Much less error prone, in my opinion. Already had 3/4 there. Okay, And this is just explaining how I got that 6x minus, how I did declaring the decimals. I actually worked it out before. Oh, well. I'd forgotten that I did that. I really ought to look over here at my screen and see what my next screen is. Save myself some breath. Okay, what about this one? Obviously, we're gonna do something here, aren't we? Huh. Wonder what that might be. Common denominator of those three fractions. 6. 6 is the smallest number that all three of those will go into. Okay, and I actually wrote it down over here. By the way, if this were a test problem, simply writing that over here is going to get you 1 point guaranteed. Because that tells me you know you need to find the common denominator on that. Okay, so what I did is I took 6 times everything on the left and 6 times everything on the right. And let's see what happens when I do that. Now, they skipped a step or two. 6 times 2 is 12. So you had 12. I don't want to use purple. I want to use some different color. 6 times 2 is 12. So I had 12 over 3x. 12 divided by 3 is 4. You see how they got that? Right here. When they distributed this 6 times 2 over 3, which simplifies to 4. This one, 6 times 5 is 30, so they had 30x over 6, and 6 goes into 30 5 times, and we carry the negative sign. See, this is what those teachers I was griping about earlier did. They didn't explain how you went from this to that. Okay, and 6 times 3 is simply 18. That one's pretty obvious. On this side, 6 times 1 is 6, so you had 6x over 2. 6 divided by 2 is 3. Okay, 3x. And then over here, 6 times 5 is 30. So that's how they transition that step. This is called clearing the denominator. When you find the common denominator of the denominator and you multiply ultimately, okay, here they just showed the multiplying the 6 times both sides, but ultimately you're going to multiply 6 times every individual term. Okay, and we're going to take that shortcut pretty soon instead of showing this step. Well, now what are they doing? They just simply combine the 4x and the 5x, negative 5x. And here they didn't do anything. This step, they did both things at the same time. They took this 3x over here by adding negative 3x, and at the same time, they took this over there by adding 18 here, adding 18 there. Okay, negative 30 plus 18 is negative 12. Negative 3x and positive 3x wipe out. These two wipe out. And this gives me negative 4x. Okay, again, you could do those in separate lines or same line. I don't care. It's up to you, whatever you're comfortable. Now, what are we going to do? We're going to divide both sides by negative 4. So we get 1x. Okay, these negatives cancel. I get 1x here. Negative, negative becomes a positive. 12 divided by 4 becomes 3. There's my solution. Question? pretty repetitive, in fact, isn't it? But I think it does help to put in these steps. We're gonna skip this one. Now we're moving into the second objective in this particular set. Okay, what is that objective? I told you there were three types of answer types for linear equations. So we're gonna be discovering those three different kinds. So we're gonna get some weird answers, okay? So here we go. Conditional by definition is true for some and false for others. Generally, that means there's one and only one correct answer. Identity, any number will substitute and work to check it. Contradiction, no number will work it. Okay, let's work this equation. You guys start on it. And I'll continue it in a moment. Let me change camera angles. Ah, no, I finally did it. I guess I was being impatient. Gotta go? Yes. We're gonna continue on this. See you tomorrow night.
You mean Thursday night?
Tomorrow is the next class.
Oh.
Yes. To answer your question. Tomorrow is just the next class. Yesterday was the previous one. Okay, let's get started on this. We got some distributions inside distributions, don't we? Okay, let's see what they put up here. Well, it appears to me that inside this, they haven't dealt with this 2 outside yet. So they took this 2 times 5 was 10. They took this 2 times negative x is negative 2x. So here's the 4 plus the parentheses minus the 2x. So, and here they took the 4 times 7 and 4 times the negative 2x. I wouldn't have done that one any different, except I would have drawn my little mountaintops. Okay, they combined like terms. Okay. 2x and negative 2x. Negative 2x and negative 2x makes negative 4x. 4 and 10 makes 14. And nothing we can do out here. Next step was we're going to distribute this 2. 2 times 14 is 28. 2 times negative 4 is negative 8. And that. Negative 8x, I should say. Now, they're probably going to skip the work steps on the next step, I would venture to say. And they're going to go straight to the answer. Now, how did they get that answer? Yeah, everything cancels out. If I take this negative x over here, I add 8x, and I add 8x, and 8x and 8x cancel out. Okay. And here, if I try to take this over there, negative 28 and negative 28, and these two cancel out. So I get 0 equals 0. Now, what does that mean? No, not no solution. Infinitely many solutions. Any number will work. Okay, this is one of those identity ones. Okay, when you get 0 equals 0, equals 3, 5 equals 5, then that is an identity equation with, and what does the answer look like on this thing? Okay, we've got the statement here, any number will produce a correct answer. Let's see if they put a possible answer. You can write the word identity. See this symbol right now? You don't need that curly Q on it, but it's kind of cute. But basically a double-legged capital R is the symbol that stands for the set of all real numbers, meaning any real number would work. Okay. Now, if it asks for you to ask you for the set notation. Okay, if it asks you for the set notation. Let me read this thing to you in English. We got the set of X values such that, or that behave in this manner according to that rule, is contained, looks kind of like a C with a bar in it. Contained is what that means. Contains all real numbers. Okay, that's what that set notation means. What if they ask you for something called interval notation? Well, what numbers would work on this problem? If I had a piece of graph paper, here's 0, what numbers would work? Everything, right? So, in interval notation, it would be every number from negative infinity to positive infinity would work. Interval notation, the graph. Set notation. Okay. 3 different ways of giving that answer. 4 actually, I guess. Counting the graph. So what happens when you get an equality out here? That means any number works. Okay, here's another one. Because time is short, let me go through this one quickly. If you want to snapshot it, you can, or if you want to copy it, you can. Okay. We cleared up this is almost the same problem, but there's a slight difference in it. Okay, we did the distribution inside. We simplified. We distributed the 2. Now we're going to get variables on the left, numbers on the right. And this time we get this number, x equals 0. Okay. Here we added negative 8x, and negative 8x makes negative 16x in this case. So that sign right there was the difference in this problem. In this case, I got one and only one answer. So we call this conditional. This problem is correct on the condition that the answer is 0, is what that literally means. So maybe the word conditional makes more sense to you now. Okay. Okay, let's look at this contradiction. Simply because it says it's gonna be a contradiction, that tells you that no number will work, right? I've already told you that, but let's see why. What happens? Okay, there's some difference in this problem. Well, it's a completely different problem than we had before. We got a distribution here, a distribution there. We've got a distribution of -1 right here. Because there's a 1 into that parentheses. Okay, so anyway, we do the distributions. Here we -5x plus 23. All right, don't get in such a hurry, wait until it's done. Well, I mean, you do what you want to, but no point in taking 2 pictures if you don't need to. Look at this goofy answer when we get all the variables on one side and the numbers on the other. We get an untruth. Okay? We get a false statement. And that's why we call it a contradiction. It is a contradiction of the truth. And the implication is there is no answer. Now, what kind of answers can you write if it asks you? Empty set, spelled out. Empty set in this form or that form. By the way, don't slash your zeros because that has a meaning of empty set, which is different than 0. Yes.
So the one on the right top, like the A and S, what is, do we put something in those parentheses or is that?
First of all, those are called, and like braces that curve around your teeth.
Yeah.
And it's just, these are set symbols that we use as set symbols in everything, right?
Right.
And this is the set containing no elements, or the empty set. Okay. You notice I spent a lot of time tonight talking language, how to interpret what they're talking about. You're going to see that all semester because that's a major roadblock for a lot of students, is simply the language of algebra because it's got its own language. And with that, I would say, go rest in peace.